Does someone have two numbers? Alright, let's try this together. So I'm going to find just the radians in quadrant 1. So I have 1 pi over 6. Class, is this 2 pi over 6? No. This one is 2 pi over 6, which is pi over 3. And class, this one is pi over 4. If I want a common denominator of 12, I'm going to have to multiply these by 2 over 2. And I'm going to have to multiply this one by 3 over 3. Let's see what we get. This one becomes 4 pi over 12. This one? And this one? Partner A, I want you to explain the equivalent fractions, and then partner B, explain which two do you think we can use to get a sum or difference. Ready, set, go. Gustavo, which ones can I use? So 3 pi over 12 and if I put 2 pi over 12, are you going to add or subtract? Question, what's 3 plus 2? So it's not 7, right? So try that again. 3 pi over 12 plus 4 pi over 12 gives us 7 pi over 12. If I reduce those, we get pi over 4 plus pi over 3. Sorry, pi over 6. What? Pi over 3. Yeah, that's right. Class, is this sum or difference? This is the sum identity of what? Cosine. Partner B, tell partner A, what is the sum identity of cosine? I'm calling the student in about 20 seconds. Ready, set, go. Mano? Crystal? Tell me with letters first. Your hint, it should have A's and B's in it. Tell me with the letters first. No pi's over fours. Manon, is this correct?
Yes.
Abigail, is this correct?
Yes.
Brooklyn, is this correct?
Yes.
Everyone talk to your partner why this is wrong. Yes, Manon? Yes, Manon?
Oh,
has to switch the sign.
C helps you change the sign. This should be a minus. Okay? Let's finish the rest now together. Actually, you guys will finish the rest. You guys have 2 minutes. Ready to go? What is your A value? Okay. A value is pi over 4. And your B value?
Pi over 3.
Marianne, tell us what to write.
Cosine of pi over 4. Cosine of pi over 3. Sine of pi over 4. And sine of pi over 3.
Raise your hand if you got that so far. So we have our A, we have our B, we put them in. Good. Natalie, cosine at pi over 4. Correct. Natalie, cosine at pi over 3. Correct. Natalie, sine at pi over 4. Correct. Natalie, sine at pi over 3. Remember, it's cosine, sine, so radical 3 over 2. For those who are having a hard time finding those, remember that's back in chapter 4a, back in January. It's finding at a trig function at an angle. Now, let me point out a common mistake so it doesn't happen to you. When you're evaluating a trig function, there are no more trig functions. What does that mean? Trig function at an angle equals an exact value. Very practically, from this step to this step, there are only numbers. No more trig functions. Okay? And then we just need to simplify here. Vincent, help us simplify. Did you see a multiply across, Vincent?
Oh. Radical 2 over 2
Over
2, 4
minus
radical 6 over 4.
Vincent, do they have a common denominator?
Yes.
So what can I write now?
Radical 2 minus radical 6 over 4.
And that's our answer. Raise your hand if you got that. In this problem, we had to find 2 angles in radians to equal 7 pi over 12. Once you have your A and your B values, then you just substitute into your formula and then simplify.
I love math. You don't love math? What's wrong with you? I love math.